Good morning. Good morning. Why don't the backbenchers just come up front? Because it seems like an empty auditorium right now. I'm looking at all of you there. Last row. It's not filling up. Come to the front. Thank you so much. That side, please. It looks nice if I can see you. Thank you so much. I didn't realize the red will not be visible on the screen. Okay, morning guys, my name is Akash and I'm presenting on a real incident of stealing of a Droid application and data. When I did this project, I was with my friend Ankur, who's sitting right here. So when the Q&A happens, he'll show his face and we can ask him questions as well. So before anything else, let me tell you what we stole. We were able to steal the application package file, which you guys commonly call it as APK. And we also stole all the encrypted files stored on the external storage of an Android device. Okay. Not only we successfully copied the application and data, we executed it on another device which we controlled, which meant that we had a rooted Android device. We were able to copy the encrypted files and the APK and execute it on another device. The important thing is the other device was rooted, and I'll tell you why it's important. Once we did that, the developers looked at it and tried to make it more secure. Okay, I'll explain why we're doing this in a slide later, but they added a device ID check, which would test, if the device ID matched, only then the APK would execute. We were able to reverse the application, add our device ID of the rooted device, and then compile it again, and it executed. Okay, so this was a safety check the developers added, which we were able to bypass pretty trivially. It was not very complicated at all. So what was this job about? Okay, if you guys don't get the movie reference, you can ask me later. It was a Chinese-made tablet running Android 4.0. It was an Indian brand. I can't really mention the name of the brand because of whatever agreements that I signed. The application contained some encrypted data. It was some multimedia data along with some other resources. Okay. We had written permission to steal. Okay, I just want to make it very clear that we are not trying to steal the data of a hard-working Android developer. We had the client wanted us to steal the data because he wanted to see if when he starts selling this, is his Android device, the data and the application vulnerable to that. He was worried about not only piracy, he was also worried about his competition. the particular sector he works in, the content is basically the important thing for them, and everyone pays for that. It was in the education space, so that would make sense. The good thing was, all the encrypted data was with us. We were able to get access to that, right? So any kind of offline attack which we could use to decrypt was available to us. We did have the encryption key, because the key was stored in the device in the shared preferences. The device was not rooted, the original tablet. We didn't have access to that. But the key was stored in the internal storage. So at some point, if we really needed to, we could have just opened the device and put the storage somewhere else and copy the data from there. And this is what we did. It was not magic, it was something very simple. Some of you might have already used this, the Android debug bridge. All you had to do was the basic command, ADB pull, and we were able to get the APK. And when we had the APK, we were able to, see the source code. It was what? Dex to jar, right? Dex to jar, and then we knew the path where the encrypted files would be stored on the device, and we were able to pull those out. It was on the, the SD card. Gone in 300 seconds. Nobody gets that reference? Okay, fine, whatever. It's not rocket science. We are not claiming that we did something really spectacular here. The reason it's not rocket science is the reason I'm here, talking about this. That it is very, very simple, and a bunch of you might be working for companies building Android apps, or you're thinking of doing this. And if you are worried about your application, if you're worried about the data, if you are worried about your client's data, you need to realize that just the way this ecosystem is, the SDK is available, there are certain precautions you need to take. And I promise I'll give you a checklist in the end, but it's not something really spectacular that we did. We had a limited time and budget in which to do a POC for the client to show them we could steal their stuff, and we did that. And before this, I had never done an Android security testing project. Okay, so I usually work as an application security consultant, so this was my first mobile security project. But the important thing is, the security testing basics, the approaches were the same. Okay, and I'm going to talk about a bit more about that. It was just common sense security testing. You may have thought about this, may not have thought about this, but just the way the, how valuable the Android ecosystem has become, this is something you might want to keep in mind. This is the hack. This is what we did. We had the APK, but what do you do with the APK? You can do some static analysis, maybe see the source code. The source code was obfuscated using a commercially available tool. So, all the function names were changed to A, B, C, and some numbers, and it was not very clear. But the hack that we did was simple. Okay? We knew finding an exploit to root the device might take some time and skill. This was a new device that we were saying. It's not available, it's not that you can just go buy it. You might be, but this particular company doesn't sell it to consumers as such. And the other thing we knew is, if it's an Android 4.0 APK, it should work in any other device running on Android 4.0, right? What is this, which is basically a strength for Android. So, if the device having the application can't be rooted, let's take the application to the rooted device. Anyone gets the reference here? Anyone? If the Muhammad doesn't go to the mountain, bring the mountain back to Muhammad? No? Okay. It's too early in the morning. So, once copied to the rooted device, we could see what the application was doing using DDMS. That's another tool available in the SDK. Called Dalvik Debugger Monitor Server. It provides, among other things, it does a lot of things. The things we were interested was process information about the app running on device connected in USB debug mode. The key is USB debug mode. We could see what files it was opening, what was the data being stored in the memory, what file it was trying to access before it would start reading the, it would execute the multimedia player to go to the encrypted part and start reading that. So we could see all of that because we had copied the APK to a rooted device. Right? So that's the important thing. We were able to copy the APK to the rooted device, and considering that I'm going to talk about some defenses and mitigations, this is an important part. That what do you need to do to make sure that this doesn't happen to your app? Any questions about this? Because I'm really good on time. I don't have a lot more slides. The key to everything. Okay. Now this is not Android specific, but this is something you may not have encountered earlier. In this particular case, the encryption key was required to decrypt the data. That's clear, right? The data is encrypted because it has some value, some business value to the client, which means the money that a consumer is paying, the client is paying to this particular, their customers are paying to the client is in this data, and it was encrypted, which is good. We didn't have the file permissions to reach the key. It was in the shared preferences. The device was not rooted. We did not have, the administrator level privileges to be able to read that file. We knew what the file was, what the path was. We could not get to the key. We decided not to go after the key. There's a simple reason for that. We weren't being paid enough because this would have taken longer. We would have had to spend more time, maybe break open the device, see how we could connect the internal SD card to some other file system and read it. But that was not the point. The point was the encrypted data is available offline. Right? Once you have it offline, you have all the time in the world to do whatever you want to do with it, if you are interested in that. So what does that mean? If a competitor is trying to steal this data, they would try to see what are the multimedia data available, being presented by this client and how they can counter it. If someone is just interested in pirating it, they would decrypt and maybe start a torrent, and anyone can download it. Then nobody would buy the client's device. The encryption conundrum. Okay, this is Android specific in the sense it's specific to any place where you hand over the key for the encryption. Why do you need to do that? Because the application, the device is going to be in the hands of your customers, right? It's not like a client server thing that you see in web apps where the server keys and everything will stay in the server and you do whatever it takes to protect the server. And physically, nobody has access to the server, right? So if you give away your device, the only way you can ensure the safety of the data is by ensuring that this symmetric encryption key is not stolen. Right? It is symmetric. It is like pre-shared. It's fastest, right? You have to decrypt 20 MB files or 40 MB files, so the key is stored somewhere. And any given point, depending on the application, and this is something you might want to really note, the key might be available in memory, in temporary files, some kind of temporary storage, or if you are like looking at something like trusted platform modules, it is part of the chip itself. Right? At some point you are trusting the key to not be stolen so that you can do operations accordingly. And that's the contradiction. You want to have encrypted data available, you want it to work, but you are giving away the key. Now you need to make sure that the key is not stolen, because once key is stolen, then it's game over. Oh, I don't think you can see the red one, I'll just read it out. But because the device is with thieves, right, someone who's interested in stealing your data, your application, right, they have all the time in the world. They are not limited by the testing budget or your time to market, like you have two months to make sure the device is secure and it has to start selling. They can do whatever and whenever they want to. Okay, and once the key is out, if it's the same key on all your devices, then your loss is basically the number of devices you have sold. Anyone could have leaked it. And if nothing works, they can always break open the device. Just because you got a device, the key is in some internal storage, you can't assume that the key will be safe. Okay? There is this particular attack. It's kind of like a movie plot attack, but it happens. It's called the evil maid attack. Okay? So evil maid basically means like you go to a country where you want to do business. Some of the people go to China, and in the hotel, if you leave your laptop for some time, the hotel maid will enter the room, okay, and they will just remove the RAM chips, you know, the memory chips, put it in liquid nitrogen, which will supposedly keeps it cool, so the memory, whatever electrical data is on the RAM is not lost, and they are able to extract that memory and store it in files. Now seems like movie plot, but it has been known to happen. So a lot of American diplomats, when they travel to China, or American businessmen as well, they, at the immigration counter, before that they weigh their laptop. They have these really sensitive scales. They weigh the laptop, they take it to China and come back and weigh it again, just to see maybe something has changed in the laptop. So which is why the point is that if the device is with someone else, you've already given it away. Just because it's inside some storage, it's inside the internal storage, does not mean that that can be broken. Okay, just going to quickly finish. This is the checklist. This is what we told the client, and this is what they implemented. So it's free consulting for all of you. You disable the USB debugging port. That's possible. You disable USB itself, which is what the client did. They basically disabled anyone being able to just connect a USB and be able to connect to the device. They didn't give internet access. They obfuscated the source code so that we could not find the device ID where we could replicate it or bypass it. And then they provided a unique key for each device. Okay, that is more for legal issues than anything else. Okay, what was the outcome? We were like success kids. The client felt assured about the security. The developers realized that they have a more secure product, and we get to pretend that we were Android security experts. Just two of us, we like the challenge, because for us it's any computing device. They're pretty standard things you can do. That's it. Questions? So for this event we had Droid chores. That's Ankur, and that's me, Akash. He did most of the hard work. He's an Android guru. So if you have any questions, you can ask. Yeah, please go ahead.
So this is if you have the physical access to the device, means you can steal the data. If it's possible to do that remotely.
In this case,
yeah.
No. There was no internet access at all, and there was no wireless access on the device.
So if we assume that if you have the access, means?
It's possible, I'm sure, but then you will need to find some kind of an exploit in one of the user land softwares running on Android. Does that answer your question?
Yeah.
Okay. Go ahead.
Hi, I just wanted to...
Here. No, go ahead. Sorry.
I just wanted to ask, what's the original, where did you get the app from? Was it a system app or a market app which was already installed?
It was a custom app built for the client.
Okay.
So it was not like a market app. We didn't look at that. The client got a OEM tablet from an Indian vendor made in China, and they got an Indian software vendor to build the app for them. But the software vendor basically sells it like a turnkey solution, but they customize it for everyone.
Right. Yeah.
So the encrypted data is totally clients. The vendor does not get access to that. Yeah. You have a question? The mic here, please.
Yeah. Other than physically contact, so is there possible, is it through NFC or Bluetooth or some ways? Is it possible?
Recently there was an attack where, because on an NFC enabled phone they were able to get a root shell. So that's again because the software running, whatever the software stack was for running the NFC on that phone was vulnerable to an attack. So that's definitely possible. If you open an interface, the actual physical is not required. Even the USB thing is an interface.
Yeah. So
right. So some data is passing. So it's possible. We haven't explored that.
So
yet.
It's possible through all means of data transmission, right?
Ankur, do you want to come to the mic?
Hello.
Yeah. Hi.
Yeah.
It's told that Google Wallet have the data stored in NFC chips.
Okay.
So how safe is it? Can we access that chip and get the data out?
I am not really sure. Do you have an answer? See, theoretically, if you have the chip and you are able to interface with it, it should be possible. But I have no idea about this. We can maybe discuss it and understand this better.
Hi, this is Srinivas.
Hi.
I have a basic question like the solution that you provided is basically to turn off the USB and the wireless. Is that the solution for a specific scenario or you are telling the client to turn off permanently?
They were worried about, for them most valuable was that the data should not be stolen, and they were okay with not having USB port available. So the USB would just charge the device. So this is not, it is for that specific scenario.
The reason I'm asking is most of the Android devices, these are the basic features that everyone wants to be.
Yeah.
Like they want to have their storage, connect to the computer and then copy it over, like where other platforms are not giving that. So if we go with this type of solution, how would exactly it will help in a bigger picture? Like data security is everyone's concern of securing the data.
Yeah.
So the basic feature we turn off, is that a right solution that we are providing?
In this case it was. But again, depending on the scenario, if you have a consumer-based application where it is going to get updated using the App Store or something, then this does not make any sense.
Yeah, thank you.
Right?
Yeah, this question is regarding the DDMS part of it.
Yeah.
So you are talking about using DDMS to go through the sources. How
Not the
exactly?
source, just process information while the application was running. For the sources we used Dex2Jar and small e, and what is that other one? J2GA.
Yeah. So using the process info, what was the information you collected?
We were able to find out the exact path where the encryption key was being read. Right? It was in shared preferences. We found the exact path where the encrypted data was, and what was the particular subclass it was calling for playing the media.
Okay.
Yeah.
Thanks.
I mean, I just want to add that whatever information we can gather, because it's a black box test, it's useful.
Hi. If you change the custom ROM of the device, it will possible. I mean, you said that like so many vendors on India, they're doing like that. So I am a China tablet user.
Okay.
So I have changed the custom ROM
Okay.
for Samsung, something like that. I have changing frequently. So is there any way to get access through this hacking technique that you demonstrated?
Do you have the SDK access still to the device?
Yeah, I have changed the entire custom ROM.
No, but what did you remove from the ROM in custom?
So I entered the...
We just use the SDK tools. If the tools are available and the basic access, user access is available through
I just
debugging.
booted the device and boot up in the recovery mode and change the ROM.
No, that's fine.
Yeah.
You can change it to anything. It's like changing the OS, right? So there need to be some tools available in the custom ROM as well.
Yeah.
So will the SDK tools still work with the custom ROM?
Some tools.
Yeah, so if tools like ADB and DDMS work, we can do that, or maybe there are some other tools.
Yeah. Okay. Yeah. Yeah. Thank you.
Given that a lot of devices can be rooted nowadays, what would be your advice to generic application developers?
In business sense, if you have some kind of any encryption available, make sure that the key is tied to the user ID somehow. That mapping will not be in the device, but will be in your backend. Let's say you are in the business of selling devices or selling applications, right? And there is some kind of a user ID, who buys the application or is using the application. If you have some encryption, make sure that the key is tied. But because that will give you some kind of a legal leverage to figure out who leaked it or something. But if it's rooted, it's not yours anyways.
Okay.
Right? unless you're using TPM or something, which may or may not. I think now most of the devices have that, but then you'll have to use those wrapper APIs. Generic advice, if you have any sensitive key, password or whatever, you need to protect it, because your entire security assumption is based on that.
Hi, I just want to know, like, how can I encrypt the entire APK so that, like, I don't expose any methods or any functions?
Do you want to answer that?
Assuming, like,
because the OS has to read it, right?
yeah, I mean, like,
It has to be in OS. You can obfuscate it, you cannot encrypt it.
okay, it's like we have to encrypt only the source code.
Yes. You can obfuscate the source code.
It won't be
not encrypt it.
encryption, because encryption means that at the time of running execution, it has to be decrypted. There will be a key for that. So that will not help you. Obfuscation definitely helps, because the second time when the developer obfuscated it, we were not able to find the device ID. We were searching, we were doing a text search to find the, the device ID we were aware of to add our own. But we were not able to do that. I mean, we could have maybe spent more time on it, but that's one really good way to make sure that at least the low-level hacking, people who don't have a lot of technical skills, that you will take care of.
Because, like, assuming if we give every access, like, we'll provide internet access and we'll enable USB, everything and all, and still we don't want our APK to be hacked or, right? For that reason I was asking. Okay, thanks.
Is there any way can you disable ADB or something?
You need to have a custom ROM then.
Yeah.
The default ROMs come with everything.
That's the problem, because apps use it for data backups, right? So that's a very, for devices which can get lost or they can get, they can break or whatever, backup is an important function, and that's being misused.
Most of the organizations or the companies, they use certificates to be pushed to the devices if they are using their company's data. So in this case, can't we use any type of that technology or the methodology to give to the client, so that if that particular certificate sends to that, it's getting hacked, it automatically wipes the data?
That's a very good approach for a company which is basically, which would want to invest in that kind of infrastructure. This particular client was in the education space, and their whole point was to give away the device so that they could sell their content. So for them to invest in that did not make any business sense, because in the end, it's the money they will spend. So for them, this did not make sense. But what you're saying is a suggestion that I made, but they were very clear that there's no point in me having this whole other infrastructure. I'll have to hire people to make sure, or find a trusted vendor for the same. So what you're saying makes sense, but in this case it didn't. Are we done? Oh, okay, we have 2 minutes. Ask questions.
This is a general question on market apps. Any idea how secure are they? We have thousands of apps that we could download, and what is the possibility that they could steal the data?
You should, there is this company called Veracode, Veracode. They have this really good paper. They do basically static analysis of applications, and they've done for thousands of Android apps, and you should read that report. It's available for free on their website. Basically, it says that the security is abysmal. It is really, really bad. And in most cases, the people building the apps are giving away your personal identifiable information, like could be the device ID or your username, passwords, just like that. They don't care. Okay.
Thank you.
But again, to answer your question, Google itself has a Google bouncer that really checks every application runtime, and if they found something fishy they're doing, they'll kick that application off. But that's not really working out, I think.
Okay, guys, last question. We'll take it off. That's right. He's asking a question. Sorry.
Hi. Great talk. Thanks. If it's so difficult to protect everything, is there a point where you say, well, the business model of protecting something is now flawed and you need to change your business model?
I didn't get your question. I'm sorry. Could you just repeat it?
Okay. So conventionally, in security, if you've got physical access to the device, then all bets are off.
Yes.
And what you're saying is that you can encrypt anything, but encryption will only take you so far because you've got all the time in the world to break it. And I'm presuming that there's some kind of offline restriction for the business.
Yes.
You can't access the network. So I'm thinking, is there a point where you go, where you start thinking that the business model of protecting your binaries or protecting your content or protecting this or protecting that is broken?
Yes.
In the same way as DRM is now considered.
Yeah, that's something I should have mentioned. I kind of forgot, it slipped my mind. In this particular case, the client accepted that given once they give out the devices, it might take 3 to 6 months for someone to figure this out. But they were okay with that because they were refreshing their content every 8 months. So they were like that people who are interested in buying it for the content will come back to me. So they were okay with that risk. At this point they were like, this is the budget we have. At this point we are